There are times when the linear equations, the pair of linear equations, are given to us directly, and there are times when a pair of equations is given to us which is not linear. Such equations are called reducible equations. Now, they can come in variable formats. One, they could be fractions, they could be square root format. I'm going to talk about this. Then they could be given in a quadratic format, and we will have to convert it into linear format so that we can solve them simultaneously. I hope you remember this particular term that we have used before. And then fifth, again, I'm going to talk about this. This is a simplified version of the previous one. So, what is a reducible equation? Look at this equation. Over here, the first term, 2 upon x. When I take x in the numerator, it becomes 2x raised to the power minus 1. Now, when the power is minus 1, this equation doesn't stay as a linear equation. For a linear equation, it is important that every variable has the exponent value as 1. So, such equations are not linear equations, but we reduce them to linear equation. So, the process of reduction is using assumption or substitution. So, only 1 upon x is a problem for us. 2 is not a problem for us. 2 is only a coefficient. So, we make an assumption that 1 upon x is p, and we make an assumption that 1 upon y is q, and we substitute these values in place of 1 upon x and 1 upon y in both the equations. This is how we carry forward. So, coming back to these five domains that we will take care of today, and these are not, this is not an exhaustive list. We are going to cover a few more in the progressive classes. So, let's look at the first one. Let's look at this example, and this is from your NCRT. Now, over here, it is important to note that 1 upon 2 is not a botheration for us. Why? It's only a coefficient. Only 1 upon x is a botheration for us. So, step 1, we make an assumption. Only 1 upon x is p and 1 upon y is q. Then, the equations will change as follows. This becomes p upon 2, not 2p, because 2 is still in the denominator, and this becomes q upon 3. Similarly, p upon 3 and q upon 2. The right hand side stays the same. Now, when we take an LCM, the equation becomes this. 6 will go to that side, multiply by 2, becomes minus 12, and bring it to the standard form. Then we solve equation 1 and 2 now, which are reduced equations. So these are reduced equations. On solving, we get p equal to 2 and q equal to 3. All of you know how to solve this. You could use any of the three methods: substitution, elimination, or cross multiplication. My personal choice would be elimination here. I would multiply this equation with 2, multiply this equation with 3. So this equation becomes 6p plus 4q minus 24 equal to 0. This will become 6p plus 9q minus 39 equal to 0. And then I will subtract the equations and I'll get the value of q as 3. Then I substitute the value of q here and get the value of p. After that, we need to find x and y. That means this value has to be substituted back here. So this value will become, the x will become the reciprocal. So x and y, if you notice, are reciprocals of p and q. So if p is 2, x is half. If q is 3, y is 1 by 3. So this is how we solve this kind of an example where the equation is not given directly as linear equation. Now, the second thing that we're going to talk about is if the coefficients are given in square root format. Now, the reducible equations, when I'm talking about here, these problems that are So these are nothing but problems that exist in the linear equations, the given linear equation. First problem we've seen about fractions. Now let us see how a square root can create a problem. Now please remember, if the coefficient is given in a square root, if it was square root 2, then there's not a problem. But when it is a square root x or a square root y, then definitely a problem. And in these two equations, we see that. So whatever is the problem, we always make an assumption with that problem itself. So 2 is not a problem for us. Only 1 upon root x is a problem for us. So we make assumption only for that much. So therefore, these equations will then change as, after making this assumption, 2a plus 3b equal to 2, because 1 upon root x has been substituted with a. So this becomes 2 into a. So 2 into 1 upon root x has become 2 into a. Similarly, minus 9 into 1 upon root y has become minus 9 into b over here. Then we solve these two equations. Again, you have three choices to solve. My personal choice would be that I will multiply this equation with 2. When I multiply this equation with 2, this will become 4a, which will match with this. This will become 6b, which will come before this. And this will become 4, which will come below this. And I'll use the elimination procedure. On solving, I get a equal to 1 by 2 and b equal to 1 by 3. But when that happens, these are not the final answers because these are our assumptions. The question was given in the format of x and y. So what would be the value of x and y in this particular case? Now, please remember, x is definitely a reciprocal here, but not alone a reciprocal. It is also that we'll have to write over here 1 upon 2, and then we square both the sides. We will square both the sides. When we square both the sides, x will become 4, and when we square both the sides here, y will become 9. So the value of x will be 4 and the value of y will be 9 in this particular case. So now we have understood how fractions can create problem and can be reduced to linear equations, square roots, how they create a problem. Now, after having understood these two, this is a simpler part. When I notice this equation, y is not a problem for us because there's no fraction here. But x is a problem because x is in the denominator. So in this case, we make only one assumption. We make assumptions only for problems, not for just everything because these are reducible forms. So the equation changes as 4u plus 3y equal to 14. And this, again, use your choice from the three choices that you have: substitution, elimination, or cross multiplication to solve these equations. My personal preference here would be that I'll multiply this with 3 and I'll multiply this with 4, and then I'll get equation 5 and 6, and then I'll solve them. Once you solve them, you get the value of u and y, right? When you get the value of u and y has been achieved. For u, you take a reciprocal because x is a reciprocal of u. So whatever value for u will come, the reciprocal will be the answer for x. Right. So now we've understood the first three. Now let's look at how can we convert what is quadratic equation to do with the linear equation. Look at this equation. Left hand side I have x, power is 1, no issue. Y, exponent 1, no issue. But the right hand side is a product of x and y. Now these are two variables that are multiplying. You are used to seeing the quadratic equation only with a square. But actually when two variables multiply, it becomes a quadratic equation. So this is a quadratic equation given in this particular format. Step 1, we divide both the sides by xy. So these five things over here are nothing but problems. These are the problems that exist in the given pair of equations. We sort out those problems and then we get to the quadratic equations. So what we saw in the quadratic equation part was that when we divide it by xy, they get to, when we divide by xy, the x and x cancels here. This becomes 6 upon y and y will cancel here. This becomes 3 upon x. xy both get cancelled, so it becomes 6. Similarly, in the second equation, which was given like this, 2x by xy, x and x cancel, it becomes 2 upon y and y cancel, it becomes 4 upon xy cancels, it becomes 5. Now, look at this equation 1 and 2. Isn't this the same equation that we covered with the first problem? I'm calling them as problems. Okay. So the first problem was like this. So that means when I get a question like this, we divide by the product of the variables that is given. We get the reduced forms and then we solve them the way we solved this question. That means we make an assumption for 1 by x as p, 1 by y as q. We'll get two equations in the form of 1 and 2. We solve them, and after solving them, we take the reciprocal of p and the reciprocal of q, which will become the values for x and y. Now let's look at what is simplified quadratic. We've understood what is quadratic. Quadratic is something like this. Now, the step one that we did in quadratic was we divided the both the three terms that were given in the equation with the product of the variables. So it becomes like this. So the simplified quadratic version looks like something like this. That means the product of the variables is given in the denominator and the right hand side is a constant. In this particular case, all that we have to do is we separate the fractions. So 7x upon xy minus 2y upon xy. Again, x and x cancel. This becomes 7 upon y. Y and y cancels. This becomes 2 upon x. Sorry, minus 2 upon x equal to 5. After that, we separate the fractions in this one as well. 8x upon xy, 7y upon xy. We do nothing to the right hand side. X and x cancel. We get 8 upon y. Y and y cancel. We get plus 7 upon x equal to 15. Right? This is just written in standard form. That means we're putting the x variable first. Again, this particular format, once we achieve this, equation 3, we can write this as equation number 3 and equation number 4. So once we achieve this equation 3 and 4, we go back to the same thing. That means the way we solved the fractions. We make let 1 by x equal to p, let 1 by y equal to q. You'll get two equations in the form of p and q. Solve them. You'll get the answers for p and q. You take the reciprocals for p and q, and the reciprocals will give you the reciprocals of p will give you the value of x, the reciprocal of q will give you the value of y. So these are basically the 5 problems that we have discussed today. There are a couple of more which we're going to discuss in the next class. So thank you so much.